Swayam Prabha. Digital India. Educated India.
So, we are in the last lecture of this module, module 4, and this was on concrete. We had extensively discussed the making of concrete, and from there we have got into the individual constituents of concrete. So, we had seen fine aggregate, mostly sand, and then we also exposed you to the other items, coarse aggregate, mostly stone, and also the other items as alternative, and finally it was cement where we ended our previous lecture. And when we discussed cement, we had discussed the water cement ratio at some point. It was mostly used for the hydration process. The water is used for the hydration process. So, we have not touched upon water, we have not touched upon plasticizers and admixtures which may be used as and when required. And also we need to know as architects very simple or basic tests that can be carried out on site to get some idea on the particularly water cement ratio as we had talked, or to check the strength every architect has to carry out cube test or the compressive strength test of the concrete which they are casting or they are using, maybe with help of reinforcement or maybe it is plain casting. Mostly we have a dense reinforcement through which this concrete mix has to pass, and water is the helper in it, gives the movement to the entire item. So, if we mix more of water, the entire thing will pass very easily. But is it so easy? Cement will get enough of water to get hydrated. So, we can keep on adding water? No. So, we have to stick to a particular water cement ratio, and why we will come to that. And we will also see the tests of concrete, go to plasticizers and admixtures and finish this module. So, what is water cement ratio? It is very simple, one can understand. It is the ratio of the water and the cement in a mix of concrete. Significance: it is responsible for the porosity of the hardened cement paste. If you remember the gel space ratio, it will increase if you add more of water. So, water will affect the strength of concrete because the intrinsic strength of concrete is within the gel. So, some values are also there which I am not elaborating, but actually this gel gives the strength to the cement, and obviously that is reflected on the strength of concrete. So, strength of fully compacted concrete is inversely proportional to the water cement ratio. So, should we go for very low water? So, can we target very low amount of water? Yes. Ideally, if we can go to a water cement ratio of 0.38 as you can see in this picture, 0.36 as you can see in this picture, is this red line can go and meet the y axis somewhere at around 60 almost 100 Newton per millimeter square. MPa is in Newton per millimeter square. You can actually pull this graph. But practically what will happen? The concrete will be very hard. Hard means it cannot move through the reinforcement as I have told, and this also you can only work in a controlled environment. Ideally you can mix it, but what will happen, the hydration, complete hydration of cement may not be possible. So, ideally it is possible to get complete hydration with 0.36 as water cement ratio, and you can gain a good amount of strength, but mostly it is seen that we are getting our concrete in this range. So, strength is between 30 to 20 and water cement ratio in this 0.45 to 0.55 range. So, why are we taking this? Because at this point the workability is very easy. Workability means the movement of the item, no segregation of the items, because those are very important. You cannot add water beyond a certain level, neither can you add water below a certain level. You can achieve ideally at 0.35 the entire hydration, water for hydration, and you can go for higher side also, but segregation may lead to reduction of strength. So, you can see the curve gradually falls when it is actually crossing a limit. So, water cement ratio is a vital point to be remembered and followed when we are going for any kind of concrete structure. So, any amount of water cannot be poured into the mixing when the concrete is being mixed, either it is ready mix, or it is coming in or it is manually mixed, or it is mixed in a rotator. Strength of concrete at any water cement ratio is the function of the degree of hydration, as I told you. So, if it is not completely hydrated, so there is not enough water, then the strength gain is not happening. It is also dependent on the temperature at which the hydration is taking place, because the temperature is important, because the heat is liberated out of the process of hydration. So, strength is being affected by these two. Water cement ratio of 0.36 under controlled condition can be achieved, but it is difficult to achieve workability, as I told you. And if water cement ratio is say 0.6, the increase in volume of the hydrated product will not be able to occupy the space filled by water, pores will be formed, strength will gradually decrease. So, for any kind of construction, it is always preferred, as I showed you, to remain between 0.4 to 0.55, 0.6 maximum, but not beyond that. And gradually, remember, higher the amount of water, lesser is the strength. You are reducing the strength. So, coming to workability. Workability, as I told you, the entire mass of concrete has to move through the dense reinforcement or network of reinforcements. It may be dense at some places like the beams or the columns, it may not be that dense in the slab areas, but yes, it has to move through. So, the ease of working or the flow of concrete will depend on the water cement ratio, size of the aggregates, that was also mentioned when we talked of the clear cover. Size will also be affected by the shape of the aggregate, surface texture, that is the shape with the number of surfaces it has, and also the proportion in which the basic three ingredients, that is the cement, sand and coarse aggregate, are being mixed, is also affecting the workability. But first of all, it is the water cement ratio. So, it is the test how to check the workability of concrete. Here you see there is a supporting jar. You can see this jar which is initially in its, so this side is open where actually you have poured this concrete. It has two supports, so you can have two supports here, and it has a dimension. This side is, it is a fixed dimension. This is 8 inch, this is 4 inch, and the whole thing is 12 inch. So that is 1 feet in height. Now once you have filled it with concrete, unset concrete mix you have put in, and then you can see you have inverted it in the picture. So this is now lifted out. So with these two supports you can actually take out the can or the container. Being of specific height, you know what is the height, and you allow it to stand for some time. So it is unsupported concrete which is standing for some time. So once it is standing for some time, it is gradually trying to go down. So once it is allowed to go down, you can take a measure of it after some time. So you will see a gap here between the original container height, and this has gradually tried to settle. So this is how we measure the slump, that is the gap between the height of the actual container and how much it has gone down on its own. That has happened actually or mostly because of the water in it or the proportion of water in it. Yes, it is not only the water, but all other ingredients are playing the role, but however it is mostly responsible for water. And if we go for general casting, we have to look into the value which is 2 inch to 4 inch, that is 50 millimeter to 100 millimeter of slump, where the water cement ratio will be within 0.55, which was our desired value. So this unsupported concrete sink in height, which is known as the slump, is a measure of the water cement ratio. This is a site check. You can check what quality of concrete is going for the construction. This is very important because if you are having more amount of water, whatever be the quality of other ingredients, the strength gain won't be happening, and also there is a fear of segregation. Now, if you have excess of water, that is called water gain. Excess of unreacted water sometimes comes out, and sedimentation of the materials do happen, as I told you, if you have more amount of water, because hydration will take its amount of water. It is not an immediate process, but after some time you can observe that water is coming out, and that is called water gain or bleeding of concrete. Unset concrete is also sometimes called as green concrete. So this slump test gives you a clue of the water cement ratio, and which also gives you an indication that yes, the strength would be of this order. Now coming to the cube test. This is always done on site before on the day of casting. You can see some cubes here, where actually with the help of a tamping rod they have been compacted, and the items are left with the material which is being cast on the day, which is a large scale casting. So you have taken samples for testing. Now what to do? On the next day you can demold it, those are inside molds. These molds are of 3-inch mold, 4-inch mold, 6-inch mold, it can be circular mold. These are usually cube like, circular is obviously cylindrical, and at least 6 to 12 such cubes are taken. Next day onwards they are immersed in water so that they can get hydrated, they can have maintain the moist condition, and they are after 7 days they are tested under a machine which is called the universal testing machine. You can see one sample put here, and it will be subjected to a compressive load and it will actually rupture at a certain point, and that is noted down. Some of the cubes are tested for 28-day test strength, and it is seen that strength of concrete is achieved up to 50% in 3 to 7 days. By 7 days around 75% strength is gained, and up to 28 days it gradually takes almost 100% strength, and it gradually, if it is moist condition continued, it may also gain further strength. However, mostly on 28 days this moist condition and all are withdrawn, and you will get almost a 100% strength gain by 28 days, and that is noted down. That is the design strength. Whether these samples comply the design strength is actually noted through this cube test. So, once this cube test is done, you can assure your client that yes, your concrete has taken the maximum strength, and that is what you had tried to achieve. So, remember, when you are making these cubes, proper tamping should be done because voids can lead to mislead you, and hence these are to be done very carefully, and the tests are to be done exactly on the same days. Now, once we have learnt all about concrete, we also need to know these were the basic materials discussed, and sometimes, as I told you many a time, that concrete is always used or mostly used as with reinforcement, and there you actually have to move these large size particles through the dense network of reinforcement, and at the same time you have to remember the setting process begins. You have transported concrete for large scale sites, you may have transported concrete from some ready mix agent. So, they are already brought to you with a delay, maybe with a delay. So, sometimes you may require your concrete to remain unset for a longer period. There comes the role of plasticizers. They are also referred to as water reducers. They improve the workability of the concrete mix, that is, it will move easier between the network of reinforcements, and these are usually concrete or combination of organic and inorganic substances. It improves the strength if admixtures like fly ash, rice husk are added. It increases the flow of the concrete. So, plasticizers are actually keeping the delay in the process of setting. They are using less, instead of putting water, they are doing the job of water, but remember they are to be added in very small portion, 1 to 2% unit weight of cement per unit weight of cement. So, with the amount of cement, the amount of plasticizer is determined. So, other properties will not change. If you add more of plasticizer, it will be segregation and delay in the setting process. So, more of plasticizers lead to segregation, higher setting time. Sulfate based plasticizers have long molecular chain. They wrap the cement particles and create a negative charge. You see the two pictures here. So, water was trapped between the cement particles here. With the addition of plasticizers, the cement particles are repelling from each other and the water is flowing outside, which is helping the other ingredients to move. So, this is the pictorial representation of the dispersed cement particles in concrete. Before it was closer, water was trapped in between, now water is free, the cement particles are repelling each other and it is allowing a free flow. So, sulfate based plasticizers are long molecular chains wrapping the cement particles, allowing them to move and delaying the setting process. Yes, the chains break and gradually the setting begins. It improves the setting time and also helps in workability. Examples of plasticizers are stearates, olates, soaps, lignosulfonates coming from the paper industry, and there are super plasticizers. So, they are added entirely in the mix and they are improving the workability of the material. Next we come to admixture. What are admixtures? They are added additionally to the mix and they change the properties. What properties? It can act as an accelerator, it can act as a retarder, or else it can be used as a cost reducer, weight reducer, giving insulation properties. But mostly if you see, they are accelerators of the process of hydration or heat evolution or the setting time, even the workability, dispersion of particles. So, these admixtures help in the process of concrete formation. They can air entrain, bring in air particles inside. They can be coloring agents, as you see, red oxide, chromium oxide. They can be reducers, cost reducers, weight reducers like fly ash, like rice ash, eggshell dust. But what are they? They are all silicates, silicon dioxide. They have 80 to 90% silicon dioxide. Eggshell dust has calcium oxide. So, all these finally help in the process of hydration, process of setting, and obviously they are used whenever they are required or recommended. So, coming to the conclusion of this module, we had tried to learn concrete as a whole. It is a versatile material and it is a monolithic item. You can have a continuous casting of it without any gap, without any joinery. Yes, but it is very difficult to correct it. Once it is done, you cannot change it, which could be done in case of a brickwork or in a case of a stonework. Here you cannot break it entirely. It can be used as mortar without the coarse aggregates, as a binder of materials, or mortar can be used as plastering item. By changing the composition of different types of concrete, different types of concrete can be made. Codes are to be followed when there is a construction and we are going to try to achieve a particular strength in it. So, codes are always there for us, but as an architect you need to emphasize on the versatility and you also need to know that what type of construction, where it is to be made, what is the availability, what is the role of each of the ingredients. As architects, if you know these, then you can always take up challenges in using concrete as a compressive material and also a compressive and tensile material with reinforcement in it. Thank you.